in the third module, which is partial differentiation and application. Well, first of all, just talk about the partial differentiation. Say I have a function, say z is equal to x square plus y square. Can someone tell me what is this graphically? Can you imagine this?
So circle.
A circle.
Okay. So first of all, I mean the equation x square plus y square is equal to 4, right? When you take this kind of equation, it is a circle. There are two variables x and y, okay, in the equation. So I have two lines, x-axis and y-axis. How do you say that it is a circle? Is you take all the points x and y which are going to satisfy this equation. That is the definition of locus you have studied in 12th standard or the 11th. So you collect all the points which are satisfying the equation x square plus y square is equal to 4. So on this plane x and y, what you have is you collect all the points, and when you see the figure after you collect all the points, that figure is a circle, and you say that x square plus y square is equal to 4 is a circle. Now we are not in two variables, we have three variables now. Z is equal to x square plus y square. So let me tell you, this is a cone in a three-dimensional space. We will see this in M2. So the structure is something like this along z axis. Okay, so it is a cone. So this is not the point of our discussion right now. So I'll come back to this equation. Z is equal to x square plus y square. So can someone tell me what is the differentiation of z with respect to x? What will be the answer?
2x.
Yes, Pratik, tell me what I should write.
2x
2x
plus 2y divided by dx.
dy by dx. Okay, and the left hand side will be dz by dx. Right? Is the equation right what I have written?
Yes, sir.
Everyone convinced with this?
Yes, sir.
So logically, this is the derivative. This is the differentiation. So you are considering y as a function of x. Am I right? Is y a function of x? Look, when you write dy by dx, it means that y depends on x, right? So in our 12th standard, all our functions were like y is equal to something, or there were implicit function, just x square plus y, x square y plus y x square. This kind of function may be there, or the functions were like y is equal to f of x. So when you write dy by dx, what is the relation between y and x? What was the relation between y and x? Anyone? So when I say dy by dx, it means that y is the dependent variable and my x is independent. So the value of y depends on the value of x, right? In this equation, do you see that your value of y is depending on value of x?
No, sir.
So in this kind of equation, so if y does not depend on x, dy by dx has to be. Say if y is equal to 2, differentiate with respect to x. What will be? What is the answer?
0.
0. So why it is 0? Because the value of y, the y does not depend on x. Whatever the x is, the answer is always 2. So derivative becomes 0 if the variable by which you are differentiating, I mean, that is independent in the given equation. So in this y is equal to 2, the value of y is not depending on x. It is constant. It is independent of x. So the derivative becomes 0. Similarly, in this case, if this y does not depend on the value of x, then this term will become 0. So dz by dx is equal to 2x. Look, there is a lot of
But
notation. Yes.
but so in the original equation, y is equal to z minus x square root over y
Uh,
and x.
yes, you are saying. So, look, of course, I can write it down as y is equal to z minus x square raised to 1 by 2. Of course, I can write it down. But I am exploring a case where y is independent. I mean, it doesn't depend on x. X and y are independent. I'm exploring that case. Okay, Prabal. So, even if it is possible to write down y as a function of z and x, or x as a function of z and y, I'm not considering that case. What I'm right now considering is ki if x and y are totally independent of each other, okay, in that case our partial differentiation comes into picture. Look what we have written here, the equation that Pratik told me. What is the equation? The equation is dz by dx is equal to 2x plus 2y dy by dx. This is the total differentiation. So in this case, we are assuming that yes, y depends on x, z depends on x, and uh, total derivative is there. But now I am exploring a case where y is independent of x. Independent of x. So in that case, what will happen is this dz by dx is equal to simply 2x. So this now is not the total derivative, but you have differentiated it partially. So you are not differentiating it completely. What you are doing is you are differentiating it partially just with respect to x. Okay, so that's why this is called. So this kind, the notation in this what we use is to differentiate it from the previous notations. It is DABA. DABA, the notation. Let me get to the next page. Z by DABA x. This is partial derivative. Partial derivative of
Respect to x.
so if z is equal to a function of x comma y. So in this case, x and y are xy are independent variables. independent variables, and z depends on x and y. So dabba z by dabba x is the partial derivative of z with respect to x. Dabba z by dabba y is partial derivative of z with respect to y. What will dz by dx mean? Anyone? What is the
Derivative,
difference now for d and dabba?
one is partial and one is total. So it means
So
y
whenever
will
we
be
are
a function of x as well.
that is correct. So whenever you are taking the derivative partial derivative, then you have to use this notation dabba. Whenever you are taking the complete derivative, like the previous answer, 2x plus 2y dy by dx. So that was the total derivative. So wherever you are taking total derivative, use d. Wherever you are taking partial, you have to use dabba. Fine. What are these terms called? Dabba z by dabba x, comma z dabba y are called first order partial derivatives of z with respect to x and y respectively. So look, there is nothing special about z is equal to f of x comma y. The same thing I can do as z is equal to a function of x1, x2, x3. So in this case, what has happened now? My independent variables are x1, x2, x3. There is one dependent variable z which depends on x1, x2, and x3. So I can take the derivative of z with respect to x1, derivative of z with respect to x2, partial derivatives, of course, derivative of z with respect to x3. Okay. So now partial derivatives can be for a function with any number of independent variables. Fine. Rules of differentiation, partial differentiation. First one, dabba by dabba x of u plus minus v. Yes, what will happen? Logically, from our previous knowledge, the partial derivative separates over addition and subtraction. So of course, in this case, I will consider u comma v are functions of x and y. So under these conditions, partial derivative of u plus minus v will be equal to partial derivative of u with respect to x plus minus partial derivative of v with respect to x. Dabba by dabba y u into v. Mohit Bharadwaj. Vipul Vishek.
Yes, sir.
Yes, Vipul, can you tell me partial derivative with respect to y of u into v?
Yes, sir.
Hmm.
Sir, U into Daba Y by Daba V by Daba Y
Yes.
plus
Hmm.
V
Hmm.
into Daba U by Daba Y.
Yes. Thank you. So the rules, the product rule, the division, the quotient rule, all of them are same. The derivatives that we have seen in our 12th standard, the rules will be as it is. The derivative of x raised to n sin x. Just one thing you have to keep in mind now, which is dependent variable, which is dependent variable, by which variable I am taking the derivative and of variable. Just things you have to keep in mind. All the other things same. So now partial derivative with respect to x of u by v. Vaibhav,
Can you tell me?
Varshney, Vaibhav.
Yes, sir.
Uh-huh.
So u into partial derivative of v minus
Yes. Yes. Further.
minus v into
Uh,
partial derivative of u
uh,
upon u
One.
square minus v square.
ओके, कैसे आया वैभव? मैं शुभम जादव, is it right?
No, sir.
हाँ. So what I should write then?
Sir, it should be the denominator should be only v square,
Okay.
and in numerator it should be v partial differential of u minus u partial differential of v.
Okay. Yes, that is correct. So you have to, uh, this can be a point of confusion, but how you have to remember is you have to take the derivative of numerator first. Okay, if you take the derivative of numerator first, this formula is denominator derivative of numerator minus numerator derivative of denominator upon denominator square. Fourth one, partial derivative with respect to x of k into u is equal to, where k is a constant, so we'll have k times partial derivative of u with respect to x. So my last simple question now, partial derivative with respect to x of x into y. Siddhant Hernar. O Patil. Preeti. Sarthak.
Yes, sir.
Yes. Can you tell me the answer?
Yes, sir. I think it will be x into delta y upon delta x plus y.
X into dabba y upon dabba x plus
Plus y. Y.
Sharvil Joshi. No. Sarvesh.
Yes, sir.
Can you tell me the answer for this? Whatever is written is correct, or you have something else?
Sir, I think it is correct.
Yes, it is correct. Okay. Let me check on. Satej, what do you think?
It's correct.
Correct. Okay. Finally, Pratik,
Yes, sir.
it is correct.
No, sir. Only y.
Only. Very good. It means you are paying attention. So I am differentiating with respect to x. So y you will be treating as constant. So since y is constant, it will come outside partial derivative with respect to x of x. So this term is nothing but 1. So y into 1, the answer is y. Okay. So when you're taking partial derivative with respect to x, treat y as constant. When you're differentiating with respect to y, treat x as constant. So if you want, you can write down a remark somewhere that partial derivative with respect to x, treating y as constant. So I will write it down here. Partial derivative of z with respect to x, treat y as constant. Or if there are more than one variables, then I will say that x छोड़ के जितने भी है, all of them are constant. The partial derivative of z with respect to y, in this case, treat all the variables other than y as constant. And this is the meaning of partial derivative. Means that whatever variable you are differentiating with, leave it, and all of the other variables are constant. Fine. Fifth property. Yes. Sarvesh, Abhay Jadhav, Amol Ambawle, Daksh is here. Daksh?
Yes,
Oh, yes, can you tell me?
yes, sir. Just a second, please.
Mhm.
So here we'll take y and z as constant,
Yes.
and then differentiating x with respect to dx, that is n into x to the power n minus 1.
What is it? F of x y z raised to n. Now tell me.
Okay.
Okay, what will you do if I tell you to differentiate f of x raised to n with respect to x? What will be the answer? Tell me.
N into f of x to the power n minus 1.
Okay. Further. That's it. It's end.
Yeah.
Fine.
Into f
Thank
dash
you.
x.
Huh?
Into
Is
f
there,
dash.
wait. Huh. So Pratik, you want to say something in this?
Into f dash x.
Into f dash of x. That is called the chain rule.
Oh, yes. Huh.
So the chain rule, same chain rule we have to use here. So we'll have n f of x y z raised to n n minus 1. By chain rule, I have to take the derivative of f, partial derivative of f with respect to 6. Look, whatever I'm writing for x, you can do it for y also. Okay. So dabba by dabba y of 1 upon f of x y z. Chinmay CS.
Yes, sir.
Yes, can you tell me this?
Log of f, f of x, y, z.
No, thank you. It is wrong. As Bhavika Kolte. As Bhavika? Anirudh. Yes, Anirudh. Can you tell me?
Yes, sir. Minus 1
Minus
upon
1 uh,
upon f of x comma y comma z का whole square
xyz whole square.
dot f dash x y x comma y comma z.
Wrong. Yes, anyone wants to make change in this? Anyone who wants to make a change in this?
So, so we will need to consider the f dash xyz needs to be the change of rate of function with respect to y.
Which means that what I have to write here.
Delta f by delta y
So partial derivative.
of f with respect to y.
So a chain rule has to be used very properly in this case. F dash of xyz means that you're taking the total derivative. We don't need total derivative, and f dash is, I mean, good for single variable functions. For functions with more than one variable, I will need to consider the partial derivative. Fine. The next one. Ayush,
Yes, sir.
can you tell me this?
So, in respect with dz is sir cos of f comma y comma z
Uh,
into d df by dz.
DF, are you sure? D?
Sorry, delta f by delta.
Delta F by delta Z.
Yes.
8. Aryan, Mihika,
So 1 upon 1 plus f xyz whole square
1 plus F of XYZ whole square.
uh, into del f by del x.
Del F by del X. Okay. So, up to this, we have made one thing very much clear, that the rules or the derivative formulas that we have seen are same. Just the one thing you have to keep in mind, by which variable you are taking the derivative partially, and you have to use the chain rule very much carefully. Okay, if you make a mistake in this, your answer may get wrong somewhere. Okay, so after the derivatives, what we have also seen is the higher order derivatives. Okay, so higher order derivatives in one variable, say y is equal to f of x. In this, it was easy, like you take dy by dx and you get some f dash of x. Then you take one more derivative of this, d2y by dx square. Then I will get f double dash of x, and yes, you have got the second higher order derivative, and things end here. But now I will write down, so z is equal to f of x comma y. I'll take the derivative with respect to x first. Say some answer I have got, whatever it is, I don't care about it. I just leave it as something dash. Now I want to go for higher order derivative. How many possibilities are there?
So now I can.
With this with respect to x, so I will have z by x square, or I can differentiate this with respect to y. How many of you are getting? Please raise your hand. So what I earlier did was I differentiated the function z of f of xy with respect to x, and later what I have done is I have differentiated with respect to x. Also, I have differentiated with respect to y. So these are the second order partial derivatives. Second order partial derivatives. Are these the only cases, or there can be something else too? There can be any other second order partial derivative cases, or that's the end. Only two choices are going to be there.
So del square v by del y square.
So del y square is also there. So if I take the partial derivative with respect to y first, again I have two choices. One will be del 2z upon del y square. The other one will be del 2z upon del x del y. Okay. So for function of two variables, I have four cases. Okay. So what I'm going to do is I'll write says z is equal to f of x, y, z. And so these are also second order partial derivatives. Okay, so if I have z is equal to f of x, y, z, how many choices I am going to get? Anyone who knows permutation combination very well?
Sir, I have a doubt.
No doubt.
Okay.
How many different possibilities we can get? So what are things I can have? Third derivative of z with respect to x. I can take third derivative of z with respect to y. I can take third derivative of z with respect to z. Oh, sorry, I have made the wrong notation. U is equal to f of x, y, z. Now, cube z, two derivatives with respect to x, one derivative with respect to y, and this kind of different possibilities are going to be there. And let me tell you one thing, that this dabba 2z by dabba y dabba x and dabba 2z by dabba x dabba y, these two are not same. So you can understand the complexity of this condition. So for z is equal to f of xy, I have four cases, and out of which these two are not always equal. Which two? Dabba 2z by dabba y dabba x is not equal to dabba 2z by dabba x dabba y. What is the difference in these two cases?
So, in the first one, we are differentiating it first with x and the whole with y, and the other one, we are first differentiating it with y and the whole with x. Then,
So these are mixed partial derivatives. I mean, these are called the mixed partial derivatives. And in this, if you differentiate first with respect to x, then with respect to y, and you differentiate first with respect to y and then with respect to x, these two in general will not be equal. Of course, under some condition, those are equal. So when we talk about higher order partial derivatives, things become very complicated. Okay, of course, in our syllabus, this condition will not occur generally. Um, but in general, still, you must know that mixed partial derivatives are not equal. So we'll just understand the notations that we are going to use for partial derivatives of highest order. So partial derivative of higher order. Notations: dabba by dabba x dabba z by dabba x. So this is also written as dabba 2z by dabba x square, or I can write it as is also equal to z suffix x comma x if z is equal to f of x comma y, then I can also write it as f of x x. This is the first and very important one. Second, dabba by dabba y to dabba z by dabba x. So what we have now? So I have differentiated z with respect to x first, and whatever result we have got, after that I am taking the derivative with respect to y. So it can also be written as dabba to z by dabba y dabba x, which is written as z of yx f of yx. Understand the notation y x जो बाद में लिखा है, that derivative is taken first. I mean, the order is preserved. Dabba y is first, dabba x is second time. So this you have to keep in mind. Third one, dabba by dabba x of dabba z by dabba y. So this will be dabba to z by dabba x dabba y, which will be z of xy, which is, can also be written as f of xy. And the last one, z by dabba y, again an easier one, dabba to z by dabba y square, which is equal to z y is equal to f y. So these two are called mixed partial derivatives. If you are writing down the notes, you can note it down. So there can be question in a theory paper that prove that these two mixed partial derivatives are equal. So in that case, you will have to follow this order. What is the order? First derivative with respect to x, then y. And in the second case on the RHS, you will have to take derivative with respect to y first and then with respect to x. And final answers you will have to show that are equal. Mixed partial derivatives. Okay. Now example.
Sir, just a second, sir, please. I was writing something.
Once you complete, do let me know.
Yes, sir, continue.
Find w by w x, comma w by w y for first one u is equal to ax square plus 2hxy plus by square. B, u is equal to x raised to y plus y raised to x. C, u is equal to x upon x square plus y square. Yes, the first one is partial derivative of u with respect to x is 2ax plus 2hy. So in this you treat y as constant. Treat y as constant and you will get this answer. As we have written the remark, partial derivative with respect to x, we have to treat y as constant. For u with respect to y, I will treat x as constant now. So ax square will become 0, 2hx plus 2by. So in the second one, b part, partial derivative of u with respect to x. Daksh, tell me. Daksh, are you listening?
Yes.
U with respect to x is
Sir, y dot x to the power y minus 1
y not x raised to y minus 1
plus
uh,
sir y to the power x dot that's it. So that's it.
that's it. Okay, anyone wants to make a change in this?
Y to the x into log y.
Log y.
Log y has to be there. The other one, partial derivative of u with respect to y will be x to the power y log x plus x into y raised to x minus 1. Yeah, please do the third one. Then you have to use the quotient rule first of all. U with respect to y, I will write it down. So minus x upon x square plus y square whole square. By chain rule, derivative of x square plus y square with respect to y will be 2y. So this is minus 2xy upon x square plus y square whole square. Please tell me the first one.
So, may
Yes, tell me.
I? So it will be uh, x square plus y square, uh, uh, x square plus y square into 1
No, tell
minus
me the final answer. Don't tell me this.
x square plus y square minus fine.
Tell me final answer.
So y square
Yes.
minus x square upon x square y square whole square.
Just a minute, Mohit. Tell me now. Yes, Mohit.
Sir, y square minus x square divided by x square plus y square whole square.
Okay. Hopeful it is right. So that's it about the introduction to the partial derivatives. In the next lecture, we'll start at 9 o'clock. Remember that on Wednesday. So in that we'll solve some more examples on higher order partial derivatives. Okay. So I've downloaded the attendance. I have also started the chat, so you can put your roll numbers there too.